Continuing in 1-2, talking about continuity, increasing and decreasing functions, we are now going to be talking about boundedness and max and min points. Boundedness talks about where do our points lie in a function? Is it bounded above? Is it bounded below? Is it bounded or is it unbounded? So we have 4 different types of boundedness, and I have drawn a very rough sketch of each one of those at the top here. So number 1 is just an upward positive facing parabola. Number 2 would be negative parabola facing downward. Number 3 is a very rough sketch of a sine graph. And number 4 is just a continuous function in all of the different quadrants that we have going on. And these will depict each one of the different types of boundedness that we have. The first we're going to talk about is if a function is bounded below. What we're going to do is if we see it bounded below, we're going to find the minimum, which will be the lowest point of the graph. And we're going to draw, and I'm going to say draw a horizontal line, but of course if you're on your calculator, that would be an imaginary horizontal line through that minimum point. Then you're going to ask yourself a question. Are there any points that lie below that line? Are there any points that lie below that minimum point? If you can answer that no, there's no points that lie below this, then we say our function is bounded below. So you can draw a horizontal line at the minimum, and then there are no points that lie below. A function is bounded above if you do the same thing, but this would have a maximum. So I would draw this imaginary line through the maximum point, the very highest point of the graph. And then I look and I say, are there any points that lie above it? If the answer is no, then we have a function that is bounded above. So you draw a horizontal line at the maximum, and then there would be no points that lie above that maximum. That is bounded above. If the function is bounded, you can see that you have either 1, 2, or multiple maximums. And if I would draw a line through that maximum, no points above it, I would say that function is bounded above. But in this particular case, I also have a minimum. And I'm going to draw an imaginary line through that minimum. And there's also no points that lie below that. So I see that this function is bounded above and it's bounded below. So therefore I say that function is bounded. It is bounded if there are both bounds below and above. It is bounded both below and above. So here, no points that lie below, and up here, no points that lie above. Our last scenario is, and it's not listed down here, but we call a function unbounded if I would draw an imaginary line through the maximum, and I ask myself, are there points that lie above that? And in this particular case, yes, because that arrow depicts that it's going on to infinity. So there are points that lie above that maximum. Here, there's a minimum, and if I draw that imaginary line, would I have points that lie below that line? The answer is yes, because this arrow represents that graph is moving on to negative infinity. So therefore, I would call this graph unbounded because there are points that lie above the max and there are points that lie below the minimum. So I would call that unbounded. So a function can be bounded below, above, both, therefore bounded, or neither, therefore unbounded. We will be talking a lot about maximum and minimums, and there are certain graphs that have many different maximums, or just more than one, I should say, and the same with different minimums as well. And so when we are referencing a local max or a local min, it's not necessarily the highest in that of that particular function, but it's just the highest in that particular area. It's the lowest in that particular area if it's a relative or a local max or a relative or local minimum. So if you see that word local or the word relative, that just means there could be more than one minimum, there could be more than one maximum, but we're just looking for a particular area. Where is the max, where is the min in that particular area? So I'd like you to grab your calculator, and we're going to find some characteristics of these two functions down here on our notes. So we're going to type into our calculator x divided by the quantity 1 plus x squared. And we're going to see what that graph looks like. And it's very hard to distinguish on our negative 10, 10 scale. So we're going to change our dimensions to be negative 8 and 8 for our x values, and negative 1, 1 for our y values. To do that, you're going to go into your window, and x min will become negative 8, and x max will be 8. Y min will be negative 1, and y max will be 1. The rest of the values can stay the same. I graph that, and I'm going to see a much clearer picture of the graph that I'm looking for. So what I'm going to do with this graph is I'm going to first identify its boundedness. Kind of a full word there, boundedness. So I see that I have a minimum and I have a maximum. So if I would draw an imaginary line through that minimum, are there points that lie below? The answer to that is no. So therefore it's bounded below. But I also see that it is bounded above. So if I would draw a line through that top one, are there points that lie above? The answer to that is no. So therefore it is also bounded above. So therefore, since it's bounded below and above, I would say that this graph is bounded. So it has a bound both above and below, therefore it's bounded. Now I'd like to look at the minimum and maximum and find the values for that. So I see, again, as I mentioned before, that I do have a minimum and I do have a maximum. So to calculate the min and the max, I'm going to do that just as if I was finding a 0. So I'm going to go second trace, and I'm going to go down to number 3, which is my minimum. Minimum was first on the graph, if you remember that, and then the maximum. Not that it matters. And the directions for finding a minimum or a maximum will be just the same as it was for finding a 0. So I'm going to move my cursor over to my left bound, and I will hit enter. Then I will move my cursor over to my right bound, which means I'm to the right of that minimum point. I will hit enter. Hit enter through guess, and I see that I have a minimum at an x equals negative 0.9999 continuous, aka negative 1, but my y value is at negative 0.5. When we go to record our minimum, we will record it according to the y value. So I will say there is a minimum at y equals negative 0.5. The x value, if you remember, with increasing and decreasing, with increasing and decreasing was along the x-axis, was the x value. So when we're representing increasing and decreasing, we're going to use it according to the x-axis. When we're recording minimum and maximum, that is going to be along the y-axis, because the y-axis tells us where the change occurs. Where the change in direction occurs is recorded through the y. It's kind of like the hinge of the graph is at the y value. So always make note that when you're finding a minimum or a maximum, it is according to the y value. So now I'm going to do the exact same thing, finding the maximum. So I'm going to go back to second trace to my calculate, and I'm going to go down now to number 4, my maximum. Hit enter, and again I'm going to follow the directions. I'm going to go to the left of the maximum, then I'm going to go to the right of the maximum somewhere along that graph. Hit enter, and I will see that there is a maximum at y equals a positive 0.5. So this is along recorded with the y for my min and max. The last characteristic I want to find are my intervals. So I see that I have 3 different intervals where it changes direction. So this will be the first, then this midsection will be the second, and then this last one will be my third. So I have the function decreasing from the interval. It looks like, remember it, increasing and decreasing as x gets greater and greater and greater, as x approaches positive infinity. What is the graph doing? So as x is moving this way, this graph is going in the downward motion. So my first interval will be decreasing. It will be decreasing from negative infinity. And where did we see the minimum? If you recall, it was at -1. I will smudge that a little, or, that was negative 0.99998. It was actually at -1 for my minimum. And then it's going to increase from that -1 all the way up to the +1, which is the x value of that maximum. And then I will decrease again from +1 to infinity. So my increasing and my decreasing through that. Then, moving to our second graph, we type that in as x to the 4th minus 7x squared plus 6x. And I'm going to change my window again to fit this graph. So -5, 5 will be my x value, and -35, 15 will be my y. And so what I'm going to get on my screen is going to look just like this picture here. So this is a screenshot of what your calculator should look like, and there it is. I'm going to do the same thing. I'm going to record the boundedness, my max and min, and my increasing and decreasing. So I'll start with the boundedness. I see that I have a minimum here. I also have a minimum here. But since this is my I guess I should say my smallest min, there's where I'm going to draw my horizontal line, and it does not appear that any points lie below that. So therefore, I would say this is bounded below, because no points are below that minimum point. So then I'm going to go find my minimums. Okay? And so I have a minimum at y equals, so I'm going to go back to my second trace to my calculate. My left bound, moving my cursor over to the left of that minimum. You can see it moving along there. So I'm to the left. I'm going to hit enter. To the right of that minimum, I'll hit enter through the guess. So I have a minimum at, now remember, I'm recording it according to my y value. So I'm going to say -24, rounding it to the hundredths, 0.06. Now I have a second minimum up here. It's a very small one, but it's still considered a minimum. I will do the same thing, going up, getting to the left of that minimum, hit enter, taking my calculator, my cursor to the right of that minimum, hit enter through that. I also have a minimum at -1.77. So those are my two minimums recorded according to the y value. I also have a maximum that I need to record, so I will do the same thing, go into my second trace, but this time I'll go down to number 4 to my maximum, and I will follow the directions along the left-hand side of the screen, bottom left, where it says left bound. So I'm to the left of that maximum, hit enter, cursor around to the right-hand side of that maximum, hit enter, and I see that I have a maximum at y equals 1.32. I couldn't read that very well. 1.32, rounding it to the hundredths. There's my max and min. Now let's record our increasing and decreasing functions. And so it does look like I have both movements, so I will go ahead and write down increasing and decreasing as it goes through, and again representing that using interval notation. So I start off as x approaches positive infinity, so as the x is getting bigger and bigger and bigger, as the x is increasing, what is the graph doing? So it starts out, it is coming into a downward motion. So I would say that that is decreasing that first interval, and I can use my picture here. So this would be my first interval, there would be my second, and my third, and then my fourth, if you can see my writing on that. So first, second, third, and fourth. And then I go into increasing. Now notice, this is at a my minimum. This is where it's changing direction. It's going from a downward motion and now I hit that minimum, and it's kind of like those little video games, that little ball hits the bottom and bounces back, and so it's at this minimum that it's going to change direction and start going up. Well, where is it changing direction? It's at the x value of that minimum there. And so if we look back at our calculator, that would have been at -2. That is inclusive because that is an actual point on my graph. And you can see here at -2, I go from 0 to a negative. I go from a positive to negative, so there's a change in direction that's taking place. So I go back to my graph, and I can see that at -2, my x value -2, it's changing direction. So now I'm increasing. So I'm going to go from -2, and if I look at the x value of my maximum, let's go look at that actually. X value of my maximum, and there it is right there still. Actually, it's not. Let's just double check that. Let's just go through this really fast. There's my maximum. So it's at 0.46, again, keeping with my hundredths. Now, from that maximum to that minimum, I'm now decreasing again. So I'm decreasing from 0.46, 46 hundredths, down to that minimum. Well, let's figure out what that x value of that minimum was. Go back and see the minimum, to the left of the minimum, to the right of that minimum, hit enter, and then we've already recorded the y, but I'm looking at the x to record where I'm increasing and decreasing. So it looks like I'm at 1.6 for the x value. And then from here, I am increasing from 1.6 to infinity, and that is represented using a parenthesis. So as we go through this, you need to remember that when recording your increasing and decreasing intervals, use your x values. When recording max and min, use your y values. And that's how we record and find our maximum and our minimum points, and recognizing our boundedness.